let's move to example 3. But as I told you, if you are new to this website, before you can understand these examples very well, you need to go back to our former lesson. And so you need to like, share, and subscribe. So by the time I upload a new video, you'll be able to get the notification. So let's go to this example 3 now. The question says, the string of a clock guitar is set into oscillation with velocity v, which is a function of tension T, length L, and mass M. Use dimension analysis, derive the relationship between V, T, L, and M. Between V, T, L, and M. Now to start with, according to the question, solution. V is a function of T for tension, L for length, and M for mass. Now, we can now say V is equal to K into TLL. Next step, don't forget, let V is equal to K into, let's use raised to power A, L raised to power B, and M raised to power C. Now, K is equal to 1. Is a dimensionless constant. Dimensionless constant. So if that is the case, then we can now have V is equal to T raised to power A, L raised to power B, M raised to power C. Mind you, once we know the value of A, B, C, we will be able to write the correct relationship between the 4 quantities. So let's write the dimension now. Dimension. According to the question, V is velocity. And the dimension for velocity, don't forget, as I told you from our former lesson, Lt raised to power minus 1. Tension. Tension is equal to force. As in the case of linear acceleration and acceleration due to gravity, which have the same dimension. So also tension also is equal to force, and force is equal to what? T raised to power minus 2. Next is length. Length, that is L, is fundamental. That is capital L. Then M is mass. That is capital M. L, that is for length. The dimension is capital L. M, that is for mass. The dimension is capital M. Now let's join it together. Note this one. The other time, from the first example, when we talk about period and we use capital T, mind you, period is a fundamental quantity. But here now, tension equivalent to force is a derived quantity. That is why you cannot say, because T also is written as capital letter, you must use the capital letter. No. Tension is force, which is derived quantity. So the dimension is written like that. So let's combine the whole thing together now and form the correct equation. So it will now give us L T raised to power minus 1 for tension now equal to M L T raised to power minus 2 Don't forget this one is raised to power A. And the next one is what? Length. L raised to power B. The last one is M. M raised to power C. You close the bracket. Now, the next thing is to open the bracket. So it will now give us L t raised to power minus 1 for velocity. Open the bracket. That's M raised to power A, L raised to power A, t raised to power minus 2A, then L raised to power B, M raised to power C. From this point, let's use law of indices. That is Lt raised to power minus 1 is equal to M. This is M. The same base, different power. That will be A plus C L. That will be L A plus B. Then for T into minus 2A. Now, we have just three terms here. Here we have 2, L and T. Here we have M, L, T. Let's do the number justice. So, left hand side must be equal to right hand side. Here, there's no M. We need to introduce M. So, by now say M raised to power is 0, L raised to power 1, T raised to power minus 1, then equal to M A plus B. That is M from this place A plus C, then A plus B, T raised to power minus 2A. Now, to compare now, to form the indices equation, M A plus C is equal to M raised to power 0. Therefore, it will now give us A plus C equals 0. L and L now. That will be L into A plus B equal to L equal to 1. Then that is, it now give us A plus B equal 1. According to equation of indices. The last one, T now. T raised to power minus 2A is equal to T raised to power minus 1. Therefore, it now give us the same base, different power. That will be minus 2A is equal to minus 1. Now we are having three equations again. Equation 1, equation 2, and equation 3. Directly from equation 3, you can now say from 3, which is minus 2A is equal to minus 1. Without wasting our time, A now is equal to half. If A is half, and within the three equations, we have we have three variables A, B, C. Then we can now say that A is half, and here now we can now substitute for A in 2. Now say substitute half. Anywhere you see A in 2, for A in equation 2. And what is our equation 2? That will be A plus B is equal to 1. Then we've already know the value of A. That will be half plus B is equal to 1. Now, we've got the value for A as half. We want to get for B now. From this point now, B now will be equal to 1 minus half. Therefore, B now will be equal to half. The next thing, to get the value for C. Now, C from equation 1. Now say and we have A and C. Luckily, we have got A the other time. We now say from equation 1, substitute half for A. And the equation 1 is A plus C equal to 0. Therefore, half plus C will be equal to 0. So C now will be equal to minus half. Now, the three variables that we slotted into the equation from the beginning, which is A, B, C, we got the answer for the three variables now, which A is equal to half, B is equal to half, and C is equal to minus half. C is equal to minus half. Now from this point, that is V from V is equal to T raised to power A for tension, L raised to power B for length, and M raised to power C. Let's put the value of A, B, C now. V now will be equal to T raised to power half, L raised to power half, and M raised to power minus half. If that is the case, law of indices, that will be root T multiplied by root L multiplied by 1 over root N. Now, the final answer will now give us root TL over N. Then that is the relationship between V, T, L, and M. That is for velocity of the string of the plug heater, the tension, which is the force applied to it, the length of the string, and the mass per unit length. Now, let's take this one as the last example. The force F acting on the wings of an aircraft moving through the air of velocity V and density P with the surface area A is given by the equation F is equal to K V raised to power S, V raised to power Y, and A raised to power Z, where K is a dimensionless constant. Use dimension analysis to find the value of S, Y, and Z. Hence, write the relations between F, V, P, and A. The question, the method still remain the same, but let's go through it and see. Solution. According to the question says F is equal to K into V raised to power S, P as density raised to power Y, and A as area raised to power Z. Now, according to the question, K is a dimensionless quantity, so we can now say F is equal to V raised to power S, density raised to power Y, area raised to power Z. Now, as usual, from this point now, what will the dimension of force? What will the dimension of velocity? And dimension of density and area? As we know before, dimension now. Don't forget, as I told you, we done the dimension for each derived quantity in our former lesson. So if you want to know more or you are new to this channel now, please try to subscribe and see our former lesson so you can understand this point very well. So F is force. That is M capital M L T raised to power minus 2. Velocity, V is velocity, that's L T raised to power minus 1. Density is mass per unit volume, that would be M L raised to power minus 3. And area, the dimension for area is L square. Let's combine them together now. That will be M L for force, T raised to power minus 2 equal to velocity L T raised to power minus 1, but this one in bracket raised to power x, followed by density. That will be M L raised to power minus 3, this one raised to power y, and the last one, which is area, that will be L raised to power 2z. Now let's open the bracket and see what this one will give us. From this one, L T raised to power minus 2, open the bracket, that's L raised to power s, T raised to power minus s, minus 1 multiplied by it, that's minus s. Open this one too, that's L raised to power y, then L raised to power minus 3y. Again, this one will be L raised to power 2z. So from this one now, here let's collect the like time, that's L T raised to power minus 2, that's L raised to power s minus 3y, according to law of indices, the same base, different power. Then this one plus 2z, then it remains m raised to power y and t raised to power minus x. Let's compare MLT, 3 quantities. Then the same thing, MLT, 3 quantity. So from there we can now compare M for M. So it means M raised to power y will be equal to M raised to power 1. Here now, y will be equal to 1. Let's take L now. L raised to power s minus 3y plus 2z, then equal to L raised to power 1. Then it will now give us the same base, different power. That will be x minus 3y plus 2z equal to 1. For t, that will be t raised to power minus s, t raised to power minus s equal to t raised to power minus 2. Here now, from there now, our minus s will be equal to minus 2. Now, the next thing, take this one as equation 1, take this one as equation 2, take this one as equation 3. We can now say from equation 1 and 3. From 1, y is equal to 1. From equation 3, which is minus s is equal to minus 2s. S now will be equal to 2. Now, since we know the value of s and y, the next thing to substitute their value in equation 2 and get the value for z. Now, we can now say substitute 2 for x, 1 for y in equation 2. And what is our equation 2? That will be x minus 3y plus 2z equal 1. And our s is 2. That will be 2 minus, the value of y is what? 1 minus 3 multiplied by 1 plus 2z equal 1. This one will now give us 2 minus 3 plus 2z equal 1. And this one will give us minus 1 plus 2z equal 1. From this point, that will be 2z is equal to 1 plus 1. 2z is equal to 2. Z now is equal to 2 divided by 2. Z is equal to 1. The value for s is equal to 2. The value for y is equal to 1. And the value for c is equal to 1. Now from this equation, f is equal to v raised to power x, then density raised to power y, and area raised to power z. Let's put the value of s, y, z. So that one will now give us f will be equal to v raised to power 2 density raised to power 1 and area raised to power 1. Now from this point now, to write the formula now. So it will now give us the formula that we connect them together will now give us f will be equal to v square p a. That's the final answer. So what question says we should find the value of s, y, and z. And we've seen that the value of s is equal to 2, y is equal to 1, z is equal to 1. To write the formula now, that will be v squared multiplied by density multiplied by area. That will be the relationship between the three quantities. It will be the end of the lesson for the uses of dimension. Under the number 3, we say that we use dimension to derive the exact physical relation between physical quantity. And you can now say that from the 4 examples given now. So all the questions given are from external questions. That is from Y, GSCE, SSCE, NECO, and so on. And we can say that with all these examples now, you can have clear understanding of this dimension. But if you still have questions under this one, as I always say, you are free to ask your question from the comment section. At the same time, don't forget to like, share, and subscribe for more notification when I upload a new video. Thank you.